All right, welcome to our YouTube channel. This is Artificial Maths Academy. We are still on the series on complex number, and this part of the complex number is Argand diagram. We want to check the Argand diagram, how we find the angle concerning a complex number. Now, let us check the meaning of Argand diagram. An Argand diagram is a graphical representation of complex numbers. Similar to a Cartesian, like your quadrats, Cartesian plane, where the horizontal axis represents the real part. The horizontal axis. Now, this is what they mean. You have your diagram. This is like your Cartesian plane, just like your x-axis and your y-axis. So this part, let me draw it a little bit boldly. Now, what they mean is that it represented our complex number. The horizontal represents, which is this horizontal line now, which is your x-axis, represents your real axis. Your real axis. And the vertical, this is the vertical, this straight line. The vertical axis represents the imaginary part, which is your I, means imaginary axis, which is your imaginary what? Part. Now, when we talk about real, just like your normal numbers. Now, let's go further. A complex number written as Z is equal to X plus IY. Our previous class, I used A plus IB. It's the same thing. On this one now, since we are representing it on a graph, or it's still a graph, or an angle format, we are going to use X for the x-axis, which is for the real part. We call this thing real part because there is no I, there is no complex number attached to it. This I is represented in our previous class. This I is representing the complex part, the complex number. Is plotted as a point x, y on this plane. This is the plane. Now, after I've given you the diagram, we are going to plot on this same table. We are going to plot the following complex number. We are going to plot the following complex number as points on a Argand diagram. So we are going to plot number 1, we are going to plot number 2, and number 3. In a point, our measure is just to identify the point of what? Of intersection. The point where the imaginary axis and the real axis meet. That is our main focus. So where do we start from? We know that we want to start the vertical line. The vertical line is your imaginary line. So we start with, and if you check very well, okay, I can just take, let's just take, this is I, this is 1, just like 1, this is the origin. This is the origin, this is 1, this is 2I, this is 3I, this is 4I, this is 5I, and so 5I, and so forth. You went further. We have negative I, negative 2I, negative 3I, negative 4I, negative 5I. Okay, let's take the same values here. We have 1. These are the real, this is the real numbers. They are not attached with I. They are not attached with imaginary number. They are not attached with the complex number. This is 2, this is 3, this is 4, and this is 5. Now this one will be what? Negative 1, negative 2, negative 3, negative 4, and negative 5. Now, this is how to plot a graph concerning a complex number, and this is all about Argand diagram. It is from this diagram you get your tan, you get your cos, your angles. It's from this graph. So now let's focus on what they gave to us from this question. This is a question. They said we should find the point of intersection of this complex number, and this one and this one. Now let's trace. On the real part, for the first one, we have -4, and this is -4. Then we have positive imaginary number. That means it's going up. So we trace positive imaginary what? Number 3. That is 3i. If you check very well, this is 3i. Y for the x is -4. So we trace. Now the point at which they meet. You see this point now? It's a point of what? We have represented this as a point of what? Argand diagram. So by the time we have so many points, we can use it to plot a graph. It's just like normal graph, you know. Now the second one is very simple. You just write it out. You write it out. Z equals to -4 plus 3i. -3i. Remember, the format of Z is equals to x plus I y. Don't forget this. Yeah. Now let's go to the second one. The second one is 3. Positive 3. You start from here. You see now? The real number here is 3. So you come to 3. The imaginary number is +2. That means I'm going up. +2. Look at +2. I here. You trace. You now write this point as in form of x, y, which is your z is equal to 3 plus 2i. Now let's get the last one. Let's trace the last one. The real number there is -2. Oh, I'll come to -2. Yes, I'll put my pin here. Then the imaginary number there is -3. -3, that means I'm going downward. Downward. So I will trace -2 to -3. Oh, that is good. And I'll put my point of intersection here. And I will mark here as what? Z is equals to -2 -3i. So this is how we represent, or this is how we draw an Argand diagram. And this is a kind of a general format. This is what you do anytime they tell you to plot a graph under complex number. This is what you are going to do. Your vertical line is your imaginary axis, which is where you have your I. Don't forget, I itself is equal to square root of -1. Don't forget this. Because of this minus, it created what? An imaginary what? Number. That I you see here is called imaginary number. This 5 you see here, 5i, is called an imaginary what? Number. Why this one? They don't have I attached to it. They don't have imaginary number attached. So they call them what? Real numbers. So at this point, we are going to, after this stage, we are able to know how to represent a complex number in a graph. So our next stage, I'm going to teach you the modulus. How to calculate a modulus of a complex number. All right. So just like I told you, I said we're going to be talking about the modulus of a complex number. Modulus is talking about the maximum, the modulus, the magnitude, okay, of the complex number. The modulus of a complex number is the distance of the complex number from the origin on the Argand diagram. I've taught you Argand diagram. So we are talking about the distance between the complex number from the origin, from that 0 point on the Argand diagram complex plane. A complex number is written as this format. I've already taught you. 1 real number plus 1 complex number. X, the X there is real part. Why the y there is imaginary part for those who are just looking at this for the first time. The modulus of z, this is a complex number, this is a symbol to write complex number, is written as this, absolute z, the absolute of z. So this is a format. Now when you go further, there's something called r. You can use this r to replace the magnitude of the complex number. This r, when you come to the aspects, there's a part we are going to solve after now, like the polar form of a complex number. We are going to use this arrow in place of this. Okay? Or when we want to find the argument of a complex number, we are going to use arrow instead of this. So, but on this stage, the modulus will use this symbol. Now, they give us a formula. That this is a formula. The modulus of a complex number is equals to the square root of x squared plus y squared. If you don't know this formula, there's no way you can solve this problem. So, they give us equations to solve. They say find the modulus of the following. Now, in questions, some of the questions, they will not tell you that this is a complex number question. From the question, you will know that this is already a complex number because it has I, and that I is always representing an imaginary number in mathematics. So sometimes they will write find the modulus of the following complex number, or sometimes they will, like this case now, they did not write it. So you have to know. Now, you should note something. That when, okay, I'll come to that aspect like this one. I will explain this aspect too. Now let's start solving. Solution. Let's take the first one. The first one is z is equal to 3 plus 4i. 3 plus 4i. Now let's look for the modulus of it. The modulus will be, from the formula, x is what? The real part. Should now be 3 squared. Plus y will be 4. You are taking 4. Forget about the I. It's equal to, this is 9 plus 16. 9 plus what? 16. Which should give us square root. Now if we add this, will give us what? 25. And this will end up giving us what? 5 as our final answer. Now let's go to the number 2. It's straightforward. It's just straightforward. Just substitute in replace of this x for the real number and this for the complex number. Forget about the I. Once you have represented this 4, this 4 they are focusing on, because the y there is already representing this yi. So let's come to the second one. The absolute value of z, or of the complex number, you put a square root. The first value has negative, so you put negative 5 squared plus 12 squared, which should give us 25 plus 144, which is equal to root. Now this will give us 9,7,9,6,3, which is equal to, now if we use our calculator to find the square root of 369, it will give us, 144 plus 25 will give us, supposed to be 1 here, supposed to be 1. So the square root of 169 is equals to 13. And this is our final answer for that.